Okay, guys, so welcome to the sort of redo of our mold making section, just because we kind of collided with the holidays. So we're going to do a kind of quick overview of the first part of mold making and casting, which is mold making. At any point, if you have questions, please feel free. Though you may want to kind of hold it till the end and we'll do it all at once in case I answer it. So the things that we're going to do, I'm going to tell you what all the terminology is and then go through kind of the very basics of making a mold, what it is, why we do it, and some of the common pitfalls that happen. All right. Molding and casting is one of those things that you just kind of need to get your hands on because you're trying to learn how to think upside down and backwards. And it can be a little daunting at first, which means you want to start with a simple project. All right. So we're going to start with kind of the basic things, right? And there's many different ways of making molds, and there's many different applications. So each one's going to be a little unique to your project. Okay. So terminology, defining it. So the mold is the form that is used to make the casting, and a mold is a negative space. It is the negative. The casting is the item that comes out of the mold. So here you see the cherry up in that corner is the casting or cast that came out of the mold, which is the object behind it that's coming apart in two parts. The reason this is a frequent sticking point is people will frequently ask and they'll say, hey, I want to make a mold of this thing. And what they really mean is they want to make a casting of this thing. So you just keep in mind, I always use muffins as a perfect example. Muffins are casting. When you make a muffin, the muffin pan is the mold, the muffin itself is the casting. All right. So is it at the pan or is it the muffin? All right. And as you can see here, we've got like there's a cool rubber mold with a shell, a rigid shell. There's an all rubber mold with these little feet. There's a chocolate mold. There's your muffin pan. And then this is a super old, like really thousands of years old mold for making metal spear points, which is wild and crazy, but these techniques have been the same forever. So mold design really matters, and you need to take the time to think about it before you work. Okay, it's gonna affect your quality, how much material you either use or waste, how hard it's gonna be, and in the end, there is no benefit to rushing it because you're gonna lose time and money by not, considering what you're doing. So don't be rushed. Anytime you say, oh, I have to have this done in 2 days, don't do it. That is not the way to go about it. All right. And each one is different. Like you can see all these little things are examples of different things that were made with different processes, and they're all molds. I really like the dinosaur. It's one of my favorites. That's really cool. But that's a huge one that's got like these metal shims to separate the mold parts. And then this green one in the corner is just a crazy organic shape that had to be cut open in a bunch of different places to get the casting out. All of them work. It's just different applications. There are generally two things you're going to run into: pliable molds and rigid molds. Either the mold or the cast, meaning your muffin or your muffin tin, needs to be bendy just a little bit. It needs to flex to let the parts come apart. So look at like the little chocolates at the bottom. Those are designed to fall out. There's nothing to grab them. That is the one situation where like you have a perfect mold that's not going to grab at all. There will be no mechanical locks. Most of the time, it's going to stick if one thing is not bendy. Okay, so just kind of keep that in mind. One of them has to be a little squishy. Okay, so most of the time, the mold is the squishy part, and the thing that's coming out of it, your casting, is the rigid part. So there's plenty of different examples here, but like doing like hard candy or something is a really simple one. These little feet here Like whenever you're doing like a mold of like a 3D printed part, maybe you want to copy, you know, the part's going to be hard, so you use something soft to make the mold, right? I'm going to not go down the cement concrete rabbit hole. It's too much. There are situations, however, when the cast is squishy and the mold is hard. Usually that's going to mean plaster and you're pouring something into it. But if you're like, for instance, these little mitts, those things are super flexible. You can just pull them out of something that is rigid, as long as you kind of take care that you're not stressing it out too much. That's absolutely something you could do. That is how duckies are made. So it's just a technique, and it's just a tool at your disposal, and it can go either way. Okay. Something that a lot of people end up doing right from the beginning is working with plaster, and there are waste molds where you get one shot because your mold gets destroyed. You can see it being chipped away right here in the corner. But this is it's a cheap and kind of straightforward way to make a cast of something that's like very, very pliable, like clay. That's the usual use. But you can see it wrecks your original right here. That's what that is. This is the clay that is sticking into the plaster from the original piece. This is the original piece, right? So you got to do it knowing that if something goes wrong, then you may lose your original. Most of the time, it's a really reliable process, though. So plaster is great for that. Okay, waste molds also can be done as an alginate mold, which is a flexible mold that gets destroyed in the process. So this is a time lapse. This is Chelsea Tipton, our pops conductor for the New Haven Symphony Orchestra, who was kind enough to model for me for a fundraising event. Okay, so I did a cast of his hands in their conducting positions. So that is a bucket of alginate, which is a rubber that is made from algae. It's the same stuff you use for dental molds to, like, you know, get your tooth molds. And you have to, it is rubbery, so he can get his hand out. It's not going to be like locked in there, but you have to, it's also kind of delicate and it tears easily. So once you get your hand out, you fill it with plaster to make your cast. So there's your muffin right there, muffin tin, all right? But in order to get the hands out, you see, I had to carve away all of the alginate because it's too stiff and too delicate to allow us to pull the hand out without either breaking the hand or the mold, right? So it's super fun, and you can do a lot with alginate, but it is water-based. Now this, I'm just showing you pictures of it. I'm not going to go crazy. Oh, it didn't. Okay, there we go. There is a process to make super precisely parted rubber molds where you embed your part in a clay bed here. And we're not going to go into extremely great detail, but you have a lot of control with this. And you can see the two halves of that rubber mold here. These are flexible, and these were 3D printed parts that were the prototypes. And it lets you control how they come apart. However, this is a very time-intensive way to do this. A lot of times you'll just do a solid block of rubber and cut it open to get the part out. Okay. But it's great for production molds because they last a really long time and they give you a super precise parting line. Okay. So pitfalls, chemicals and trapped gases. Bubbles are your enemy. We are always fighting bubbles. They are the devil. There are many options for materials. And you kind of start with, what do you want your final material, like your final result to be, and work your way back from there. You want to use the simplest process you can and the simplest materials. But since there are so many, I recommend just asking for help. And sometimes the answer to how do I make this mold is you don't need to make a mold, you only need one of them. 3D printing, you know. mold making is not always the go-to, but people see things online and they're like, oh, this is what I obviously have to do to make this thing. That's not always the case. So depending on what you need the thing to do, like what you need your result to be, and the sort of process you're kind of able to handle, it can change. There is no harm in asking. All right. I'm going to give you kind of the basic tools to sort of start like narrowing down your materials. Okay. We end up having a lot of Reynolds or smooth-on products on hand, but there are many, many different suppliers out there. And we're just starting to do a regular bulk order so that you guys can enjoy the benefits of reduced shipping on this stuff by we all order it together so that it's less expensive for everyone, which is, part of the benefit of being a MakeHaven member. So I am not going to go crazy with this, but there are, oh, did I just click a link? I'm sorry. Oh, haha. There we go. I'm not gonna go crazy with this, but we do have on the wall downstairs by the casting station, we've got charts that are going to tell you information about materials. So if you're like, ooh, I need something that's going to give me a half an hour of working time, this is an easy way to go and find it. Okay. Notable things are the spec chart, but also we have a shore hardness scale and a viscosity scale that kind of give you an idea based on like real world things you're familiar with, so that you know how a material is going to behave. So that's something to check out at the station. The first part of any casting material where you're going to, like rubbers, that you're going to be mixing two things, which is most of them, almost all of them, even plaster, it's plaster and water. You need to know what your mix ratio is to get the right result. That can either be curing or, well, I mean, it's definitely a cure, where you need a certain quantity of part A and part B to react with each other to make the thing harden permanently. Okay. And if that doesn't happen, if it doesn't have the right ratio, it may cure slowly or not at all, or way too fast. So, you need to know whether you're mixing by volume, meaning you need like 2 cups this full, mix them together, that's the ratio, or by weight, meaning you have to put it on a scale to know exactly how, like whether it's correct or not. And you need to check that before you get your material, because if you don't have an accurate gram scale or you're not comfortable with that, it can be a real problem. Right? Mix ratio by volume is always going to be easier. Okay. So for your purposes, when you're starting out, your pot time or your pot life, your cure time, and whether the stuff heats up as it cures, those are going to be things that are going to affect how it performs for you. And the rule of thumb is give yourself more time. You always want to get a material that's going to give you enough time to get everything done, because you don't want to be rushed. You don't want it to suddenly set when you're not ready for it, because that's when you waste materials, right? So pot life is how long you have to work with it before it's too firm to flow or it's not going to behave the way that you need. The cure time is how long before you can break it open and use it. And then exothermic reactions. I think I have the slide here. Okay, an exothermic reaction, you always want to make your material be in the thinnest, widest amount possible, rather than if you take the same amount and it's in a bucket, it's a large thermal mass. If you pour that onto like a sheet pan, it's the same amount, but it's thin and it's spread out. The reason for that is with those exothermic reactions, when they start, they're based on that thermal mass. So the bucket is going to heat up way faster. It's going to cure way faster. You might not be ready for it. So laying it, like, when you're working, if you've got like a lot of something, space it out, spread it out to give yourself extra time. Okay. That's a frequent point of crying when you've like bought some expensive epoxy and you leave it in your bucket and you turn around and it's like, it's kicked, it's hard, it's done. You didn't pour it on the thing you wanted. So the mix ratio, the mix ratio is how much of part A and part B. And remember, it's either by volume or by weight You need to check the material when you're getting it, okay? So viscosity, the easiest way to think about viscosity is how liquidy is it? How close to water? And that matters because something that is thin can run around and get into little, tiny little details, little nooks and crannies. It does not create bubbles in the same way that something thick would. Like imagine pouring water on something or brownie batter. It's the same kind of a thing where it's going to behave differently, and that can be good or bad depending on what you need. There's a viscosity scale downstairs, and it's like, you don't know what 2000 centipoise is, but you know what honey looks like and how it behaves. And it's something that you want to know, okay? So for the record, if you remember to check it because it can matter when you're doing detailed stuff. And then the last thing is shore hardness. That basically just means how hard is the finished product. There's a chart. It goes anywhere from like gummy bear to hard hat, depending on the different ones. And this is a durometer that shows the hardness. It's basically you stab it with this little pin until it stops going, and that's the hardness. We don't have one. It doesn't matter. So there's a lot. There's a lot to consider. And starting out simply, doing a simple little mold first is the most illuminating possible thing you can do, right? The answer is always yes, we can do it. The question is how and in what way. Okay? I think that sometimes the answer, as I said before, is you don't need to make a mold for this. But kind of as a short rundown, the final material you need can dictate the kind of material you have to use in order to mold it. Like for instance, alginate is water-based. You can't put certain plastics into it because they'll foam like urethane plastics. Okay? How complex is it? If it's really, really like crazy topology, you're going to need a softer rubber to be able to let go of that. If it is smooth and flat, you want something that's pretty firm so that it holds its shape. And then how big is it? If you're trying to cast concrete, you need a mold that can hold up to that weight once it's full, because you got to think about how it's gonna, if you make a mold shell out of paper mache and fill it with concrete, imagine what would happen. It's not gonna work. And then another thing under the heading of preparation, if your mold has a defect or something that you simply don't like, every single cast you make from that mold is going to have that defect, and you're gonna have to clean it up or change it or work on it in some way. Sometimes that doesn't matter if you're only making a couple of things, but if you're making 100 of something and you have to spend 5 minutes cleaning up each one, that time adds up very quickly, and it can also affect the quality of your product. So you never want to rush or sort of use half measures with your molds, because it is not saving you time if you have to do a lot of castings, okay? If you're doing quick ones, then doing a cut mold where you just cut through, it's gonna have a messier like parting line, but it's faster to make the mold than doing that layup process that I showed. That the layup is gonna be perfect. So, it kind of, it's gonna save you a lot. This will be a lot of cleanup, but you saved maybe like, a couple hours making the mold. And this is going to be a couple of hours of extra work in order to, get yourself beautiful, perfect casts, right? So it really comes down to what's your time worth? You spend more time to use less material and more material to save time. And, taking the time to engineer can really pay dividends in the end. I can't reiterate enough, starting out simple. If you're using something that requires like some sort of weird mix ratio and you don't have enough time, like, it gives you 2 minutes to work, that is not a beginner material. Okay? You want a lot of working time and an easy mix. Okay. So I'm gonna kind of just compress this down. Like I said, bubbles are the enemy. We have 2 ways on hand here to get rid of bubbles. we have a vacuum chamber that sucks the air out, and we have a pressure pot that squashes the bubbles down so that they're not visible. Both of them work really well. And they're gonna, what's the easiest one to use is gonna depend on your project. The one thing that I will say is that if you plan to do pressure casting in the future, if you're going to make casts, meaning muffins, okay, if you're making muffins under pressure, then the mold, meaning the muffin pan, has to have been made under pressure as well. Okay? If you put a mold that was not cured under pressure, meaning it did not completely harden while under that pressure, then everything comes out looking like a pickle. All of your casts will have they'll be deformed and have little bubbles all over them because the material will get forced into all these tiny little air bubbles from the mold that was made at regular atmosphere. So that's just a thing to keep in mind. All right. Yes. The vacuum chamber removes it. This allows you to get most of the bubbles out. You're never going to get all of them out. So it might work to put it in a pressure caster, but it's not going to be the same as one that was done. Like I would not personally trust it, but you can do it like kind of a test and see if it's good enough for you. Typically what the vacuum chambers are used for is one, to remove the bubbles out of the rubber you're using to make a mold that can't fit into the pressure pot. Like you have to make it, just on the tabletop because it won't fit in to do another way. It'll get a lot of it'll get most of the bubbles out. You can also, it's known as degassing. You can also degas the material pouring into it. It is worth noting that not every material will degas successfully. Some things just create bubbles forever because there's like a chemical component to putting it under a vacuum. And it'll say in the material sheet, you're going to want to read those bulletins, vacuum degassing not recommended. Like it'll say something like that. Okay. But a lot of times you can do that to get a very clear cast as well. But that's for like when it just won't fit into the pressure pot. I always pressure cast if I can. And so, yeah, it's this one sucks all the air out. This one squashes all the air down. But, in order to keep those bubbles compressed, you got to let it cure so they can't reinflate. So, all right. So, for managing bubbles, anytime you have a little part, it's like imagine like an air pocket in a cave and you're swimming through the cave. If you come to a little pocket where it holds air, you can bob up and you're out of the water. Those little air pockets are the thing that will cause, like, if you're casting a hand, the tip of the finger won't come out because it's like this, and an air bubble formed here, that kind of a thing. So, like managing how the air can get out, you need a way for the material to get in and the air to get out. It's like plumbing. There are vents or sprues, which are part of the process that leave a little channel so the air can escape. And that's kind of part of the design. Okay. And then there's going to be a spot where the inlet or the pour spout where you are able to pour the material into the mold. Okay. All right. Cure inhibition. This is something that happens. It's a really select number of things, but you need to be aware of it. There are certain materials or substances, when they come in contact with certain casting materials, silicone being the main one, they will cause it to never ever cure. Okay. So the notorious one is sulfured clays and silicone rubber. The silicone will never cure if you put it on a sulfured clay. And some silicones, different types of silicones will not cure if they put next to each other. A lot of times they stick together, but not always. So, checking that bulletin that you're going to get, there's just going to be an info sheet that goes with materials. You read it, and if there is an inhibition, they will say so. okay? It's extremely important that they do that, and so they do, but you have to know to look for it, right? Most things, it's not gonna come up, but when it does, it's not great, okay? And it will, like, literally never cure, which is just sadness, right? One other notable one, some body-safe silicone rubbers do not like aloe vera, and that will cause it. So if you have like an aloe vera hand lotion on and you put your hand in it, you're just going to be covered in slime until you wipe it off. So, yeah. Okay, release agents. They're things that keep stuff from sticking to other stuff. And in order to get your cast out of your mold, you need to use a release. They can be liquids or powders or sprays. It is the PAM you spray your muffin tin with before you put your muffin in. Okay, back to muffins. Or cupcakes if you like. However, a cupcake paper can also be a release, you know. Waxes, good old Vaseline, and then there's specific mold releases, which we do have here at MakeHaven. And you do not skip this step if you want to ever get certain mold materials off of your cast. Like if you forget to coat, say, a urethane mold with mold release, or one part of the plaster cast in a plaster molds, like when you're doing a waste mold, it just becomes a solid block. So that's sad. And this is something that everybody does once you do the 5-second stare, realizing you forgot to release the thing you just did. Silicones are great because they don't stick to really anything except themselves. So if you forget, they'll still come apart, but that is not always the case with all materials. Baby powder is good also for creating a dust that will keep things from sticking. However, one thing I will say, do not ever spray a release in a wood shop, because if it gets on someone's projects, they will not be able to finish their project. It will not, the release will keep their varnish or whatever from sticking. So you just don't, you may think it's like, oh, I can just duck in here to spray it. Do not do that. That is mean. On the other flip side of that, if you leave something out and it gets covered in dust, that can also cause stuff to not laminate when you want it to stick. So you just got to remember that dust can be a mold release, just like, you know, Vaseline and other kinds of slime. Okay. So, and never spray in the wood shop. It's just like cruel. It's bad karma. Okay. So open molds are the simplest ones. And I actually like people to start out with these. I think this was Corey's countertop. He made a mold out of, he made a concrete countertop by making a mold with some foam and pieces of wood and other stuff just to make a big block. And you can make a mold out of anything, doesn't matter, as long as it's watertight. So that's what that is. But then also, you know, good old candy molds, like super simple. And that waste mold I showed you of the face, the relief sculpture earlier, that was an open face mold. So it's just open from the back. So life casting is like one of the easiest things, super fast. This is alginate. You can make a really nice copy, and you can see the level of detail this gets. We have alginate here, and this is a really, really great beginner project to kind of just wrap your mind around it. And then you can have a phone or finger or whatever, you know. You can do the whole hand if you're feeling sassy. So one thing to note, some resins, urethane resins specifically, can't be cast into this mold to make a resin, like a plastic resin part, because they foam when they hit water, and this is mostly water. Okay, so this is a situation where the mold material will cause a reaction in some casting materials, meaning you'll have a foamy muffin. Okay, so but it's very fun. Like life casting is a great thing, great way to do. So 2-part molds. Basically, they need to hold their shape and they need to line up. And the way that you make them line up is by keys and registration marks. Like you can see there's a little bump here that corresponds to a divot here. They're known as keys. Okay. And This is a mold that has a thin rubber layer around the part to get the detail, but it needs, if you were to peel that out, it'll be floppy. It won't hold its shape, especially when it's full. If it's full of plaster that's heavy, you need a rigid shell that the rubber part of the mold snaps into to hold the shape, and then it's like a clamshell, it just goes together. So it's important to use the kind of materials and techniques that make sense for what you're doing. If I were doing a thumb, I would never bother to do something that's complicated. You don't need it. Like a block mold will do. But for some things, once you get to a certain size, you sort of have to drift into this technique. And when you are designing the mold, you need to do it in such a way that it comes apart as easily as you can manage. And sometimes you need to make another part to the mold. Maybe it would be a 3-part mold. You're always going to have a line like at the meeting part of the molds, and how you design your mold is going to determine how much cleanup you end up doing. So there is also, as I was saying before, you need a place to pour the material in, and you need a way to let air out. So injection molding, I am actually, it's super interesting, and like this is a really cool video that can show you how things are made. Like everything we use, our phones, our parts of our cars, it's all done with injection molding. This is like the gold standard for manufacturing, and it's super cool. It's not something we're going to cover now, but it's worth looking into because we do have that capability if you really want to go down that rabbit hole. But those molds have to be milled out of blocks of metal, and then the liquid melted pellets of material are pressurized into them. And it's a whole other thing. There's engineering that goes along with it and everything. It's very, very cool. We're not going to quite do it now. So bonus. Vacuum forming is something that we can do that is very fun. And if you're doing a simple like candy mold or something like that, you absolutely can use this as a way to make molds. So, you know, if that's something that's interesting and you're doing a part that doesn't have any kind of mechanical lock to it, meaning it's not grabbing, so it doesn't have to flex around it, then it's absolutely something that is available to you. The thing with vacuum is that you need a way for the air to suck the, like see all these little air holes? You need to have a way for it to like really, really like suck the material down onto your form, and you have to create this blank form to pull the hot sheet of plastic over it. And like this right here, that didn't go exactly as planned, and that hammer was sort of entombed in there and had to be cut out, but this one popped right out. Let me know if that's something that's of interest. So that is, I think, as far as we're going to go with this. It took longer than I hoped. But probably, if not, it's gettable. Like we've got acrylic and other things. So this is super fun. If you like print a bunch of little candy shapes or something and make yourself a candy mold, you can do a quick little like that. That's super fun. And it's great for other things like masks that are like open and don't have any like grabbing undercuts things. So I think I can stop sharing, and good job, guys. You made it this far.